Have you ever thought about time? Does it flow the same for everyone, like a steady, constant river? Or is there more to the story? The universe holds many secrets, and time is one of its biggest. Imagine you are on a spaceship, zooming through the cosmos. Would your watch tick the same as a clock back here on Earth? This isn't just science fiction. The truth about time is stranger than you might think. It is a fundamental part of our universe, and it behaves in surprising ways. Out there in the great expanse, the rules can be different. We must look to science to understand time's true nature. We are going to explore time dilation, a real phenomenon that will change how you see time forever. Let's talk about a brilliant mind, Albert Einstein. He was a game changer. His ideas shook the world of physics, especially our understanding of time. He showed us something amazing. Time is not what it seems. It is much more flexible. Einstein had a famous idea, the theory of special relativity. It says the speed of light is constant, always the same for everyone, no matter how fast you move. This simple fact has big consequences. One is that time can stretch. It depends on how fast you are moving. Then came his next big idea, the theory of general relativity. Einstein said gravity is not just a force, it is a curve in space and time. Massive objects warp space-time, and this bending affects time too. Time is not absolute, it is relative. It depends on your speed and the gravity around you. Einstein's theories point to two main ways time can be different. The first is called gravitational time dilation. Stronger gravity makes time pass slower. Imagine gravity as a hill for time. The steeper the hill, the harder it is for time to climb. So time flows more slowly near a very massive object. Think about Earth itself. A clock on the surface of Earth ticks slightly slower than a clock higher up, like on a mountain or in space. The difference is incredibly tiny, but scientists can measure it with very precise atomic clocks. The second way is velocity time dilation. The faster you move through space, the slower your time flows compared to someone moving slower or stationary. Imagine twin astronauts. One stays on Earth, the other zooms off in a fast spaceship, traveling near the speed of light. When the spaceship returns, the traveling twin will be younger than the twin who stayed home. This is not a paradox, it is physics. Time literally passed slower for the traveler. Speed has stretched their moments. These ideas are not just theories. Consider astronauts on the International Space Station. The ISS orbits Earth very fast, about 17,500 miles per hour. This speed causes their time to slow down. But they are also further from Earth's center, where gravity is slightly weaker. This weaker gravity makes their time speed up. For ISS astronauts, speed wins. The velocity time dilation is stronger than the gravitational time dilation effect. So astronauts age slightly slower than people on Earth. How much slower? About 0.007 seconds less for every 6 months. Astronauts are tiny time travelers. Now let's go to an extreme place, black holes. These are objects so dense their gravity is incredibly strong. Nothing, not even light, can escape once it crosses the event horizon. As you get closer to a black hole, gravitational time dilation becomes extreme. Time would slow down dramatically for you compared to someone far away. If you could hover near the event horizon and then return to your distant friends, you would find they have aged much more. Time almost stops at the event horizon. You might think this is all just cosmic stuff, far removed from our daily lives, but it is not. Einstein's ideas about time are essential for technology we use every day. Think about GPS, the global positioning system. It helps your phone know where you are. It helps cars and planes navigate. It relies on super accurate time. GPS satellites orbit Earth. They're about 12,550 miles up, and they travel at about 8,700 miles per hour. Their speed makes their clocks run slower by about 7 microseconds per day. But their higher altitude means weaker gravity. This makes their clocks run faster by about 45 microseconds per day. The net effect is that their clocks run faster. If GPS engineers did not account for this, the system would fail. GPS relies on tiny time differences to pinpoint your location. Without corrections for time dilation, GPS errors would build up fast, several miles every single day. Your navigation app would be useless. So relativity is not just for scientists. The universe is a wondrous place. There is always more to discover about time, space, and everything in between.